and welcome to the Impact Environmental video blog. Our firm is a solid waste management and environmental consulting company based in New York, New Jersey, and Pennsylvania. At Impact Environmental, we strive to provide our clients with superior services while acting as a resource to educate and inform. We hope you enjoy the following blog. Please feel free to leave comments and feedback on the content. Afterward, visit our website at www.impactenvironmental.com or follow us on Facebook. From all of us at Impact Environmental, welcome to Solid Ground.
Bullsliver is a colloquial name given for the inorganic silt encountered throughout New York City. The material is being unearthed routinely now that the city's aging infrastructure and building network are undergoing replacement and/or upgrades. Inorganic silts are fine-grained soils with little to no plasticity. They're not only difficult to build on and in, they're difficult to dispose of. Hi, I'm Rich Parrish, President of Impact Environmental, and this vlog is intended to summarize some of the issues facing engineers, contractors, and developers when dealing with Bullsliver. I'm coming to you today from Impact's Soil Laboratory at its corporate headquarters in Bohemia, New York. Let's start by talking about Bullsliver's obvious characteristics. The name Bullsliver seems absolutely appropriate. It's characteristically red, and it shakes like jelly when you vibrate it. The first use of the term Bullsliver appeared to have come from the turn-of-the-century underground construction workers of New York City known as the sandhogs. When we use the term organic silt, we're referring to a material with no organic content, that is, no leaf litter or wood. There are written accounts of sandhog workers performing services in tunnels and leaning against what appeared to be solid walls, only to have them liquefy from their body weight. Certainly, tunnel safety must have been greatly compromised due to this material. Currently, many of the large-scale excavation projects occurring in the New York City area, such as East Side Access, the World Trade Center, and the Hudson Yards projects, involve Bullsliver, and it shows the prevalence of Bullsliver in the geographic area. I have with me here today John Herbig from our office. He's our operations manager, and he was involved in a lot of the projects that involve Bullsliver, like the World Trade Center. John, how are you?
Good. How's it going, Rich?
Great. And I wanted to talk to you first and ask you the question, what was it like working at the World Trade Center?
The World Trade Center was a great project to be involved in. It was an honor and a privilege, really, for me to work down there. There was a great sense of purpose at that job site, a great sense of camaraderie between the workers. We all knew we were there for a very special purpose, which was to build a monument and a tribute to the victims and the families of the victims of the terrorist attack of September 11th.
Oh, that's great, and we thank you for the time you spent down there. I know you spent a lot of time down there. John, getting to the physical characteristics of the material, the Bullsliver, which of course is the characteristically red material, you know that, it's probably all over your shoes.
Sure.
The Bullsliver, it had been unearthed for the first time in decades, and I know it had to have been dry. Can you talk a little bit about that dryness and what that kind of problems that created or issues that created for you?
It was a very dry material. That was something a characteristic of the material that caught my attention right off the bat. We noticed that the truckloads of that material were going out and being weighed, and it was uncharacteristically light.
I know when it did get wet, it got very heavy. It seemed like we lived in a world of extremes. It was either too heavy or too light, and I think that speaks a lot about the material. When I was down there on occasion with you, we did notice that when it rained, the material tended to really shrink up. Did you get a sense for that? How much of that shrinkage? You were down in the pit, so you kind of got a feel of the volume reduction from that wetting of the material.
That's absolutely correct. We saw a lot of shrinking with that material. And if you added enough water, if Mother Nature decided to rain enough on us, it turned into soup. It was almost impossible to work with.
Yeah, it lives up to its name, doesn't it?
Absolutely does.
As far as being able to load that onto trucks, I know when it gets wet, it starts to take on somewhat of a liquid appearance and some of the characteristics of a liquid. Did you have any trouble? Did you have to line the trucks, or were the trucks sealed in some way to prevent leakage?
We did have to line some of the trucks, and all the trucks were sealed, but it was part of the nature of that material. When you haul that certain type of material, you'd put it in the truck would leave the site to come to the facility, and just the vibration of the over-the-road action would actually change the nature of the material. The water would actually settle to the top from the vibrating of the driving of the truck, and it caused a lot of issues. The trucks would get to the sites, the dump facilities, and the facility managers would call up and say, "You sent us liquid." And the project super on the other side of this project where the material came from said, "When I loaded it, it was a solid." No, this is absolutely not. Everyone thought they were on a different page, and the real mystery was the change of the material during the transport.
Sure.
So very interesting.
We saw samples of that when we worked with it here at the laboratory. I think even more interesting, and probably what was more problematic for some of the excavators out there, was the fact that when you put something on it that vibrates, like a hard, heavy piece of equipment that is operated hydraulically, the vibrations must have really acted to make that material act uncharacteristically unsolid. So I'm imagining that was quite challenging. So you really got a sense for how difficult it is to work with this, didn't you?
It's very difficult to work with, yes. It was that particular project, very difficult to work with, yes.
Well, John, thank you for joining me. I appreciate your time. And again, thank you for your time down at the Trade Center.
Anytime, Rich. Thank you.
Traditional well point-based dewatering systems are ineffective because of the material's low permeability and low transmissivity. Where the material occurs in pockets, it can be a dangerous condition. It can represent that portion of a site which is not dewatered, not a condition you want to be surprised with. The material can be improved through compaction or the injection of high solid materials such as cement, concrete, or grouts or bentonite products. This acts to bolster the material's structural capabilities underground and makes a material that's difficult to work with structurally capable of handling a heavy load. It's shown here dry. One of the field tests to determine if you're working with Bullsliver is to rub it when it's dry. If dust can be detached by rubbing it with your finger or a towel, it's likely an inorganic silt, such as Bullsliver. When air is applied to it, you can see that it's quite dusty. When wet and drained, a pat of this material in your hand will expel enough water to make its surface appear glossy. If the pad is bent between the fingers, its surface again becomes dull and the water re-enters the soil. Now let's take it out to the field so we can really get a feel for this material. Here you see large volumes of Bullsliver and other wet, clean fill materials stockpiled.
As you can see, one of the ways of handling this material is to mix it with porous materials such as brick, block, concrete, or rock that's been crushed to size. It creates a better distribution of particle sizes and allows them to become compacted. Sometimes we even need to add Portland cement or natural occurring limestone cement.
Our firm is often tasked with disposing of Bullsliver in an environmentally responsible manner, a technique that effectively recycles the material known as beneficial reuse. It's often very necessary to have the material stabilized in an interim location prior to being delivered to its ultimate disposal location. Without proper stabilization, the material will be very difficult to drive on, move, or transport from point to point at the disposal facility. To me, one question remains. How did the first generation of New York City heavy construction contractors deal with the Bullsliver given the minimal technology of their day? If you have some answers and you wish to share them with us, please write in. We'll include it in the content of our vlog. Thank you for watching. Feel free to visit our website at www.impactenvironmental.com for more industry-related content. And welcome to Solid Ground.